It explains how to manually define dimensions for features like holes, using control key commands. Also how using standard dimensions and to link dimension values with variables, simplifying editing and association processes. The importance of tables in defining multiple variables is highlighted, showcasing how tables created in programs like Notepad or Excel can streamline parametric part creation. Associating tables with drawings allows for efficient management of numerous variables and variants in technical designs, emphasizing practicality in complex projects. Let's open drawing D1 that contains the hole. Note that the hole dimensions have not been defined. Let's do this now. Before that, let's remember the concept of auto-associative dimensions and standard dimensions. Activating list of variables in chronological order. When the rectangle was created, the length and height dimensions were automatically created. This type of dimensions created automatically after an entity, such as circles, rectangles, contours, etc., are called auto-associative dimensions. The text color of these dimensions has a different color from the dimension lines. In these dimensions, I can correct the dimensional value of the dimension line by clicking on the dimension with the Control key pressed. In this case, it is the variable L. I will manually create the whole length dimension. Click on this dimension with the Control key pressed. The system opens the construction command used to create the dimensioned entity, in this case, the hole. It shows the construction parameters of the hole. The first parameter is the property box. Note that the hole dimensions are associated with the LF and DF variables, canceling the correction. Open the list of variables and see that LF and DF depend on the variables L and D. Editing L to 80, the LD variable is modified. Note that the dimension text has the same color as the dimension lines. How do I use standard dimensions to indicate which value displayed in the dimension text is associated with a variable? Correcting the dimension of the hole length. In the Settings and Variable option, indicate the LF variable associated with this dimension. See that now when creating the hole diameter dimension, I already informed that the DF variable is associated with this dimension. The associated variables are visually shown in the two dimensions. Returning the value of the variable L to 100. This construction has only 4 variables, but imagine if it had dozens of variables. It would be very laborious to answer all the variables through questions or by editing them manually. An interesting way is to create tables that define the values of these variables. Using tables, simply select the position of the table, and the part will be created according to the parametric information of a given line in the table. The table can be a TXT file created in Notepad or a CSV table in Excel. The simplest way to create associative tables is to use tables with a question. Using Notepad, create the TABD2 TXT table. Variables and column values must be separated by a comma or semicolon. The first line of the table must contain the list of variables, in this case the variables L and H, and 3 more lines with constructive variants. An important tip is that when creating drawings and parametric parts associated with tables, save the tables in the same folder as the part or in a specific folder for creating tables. This way it is simpler when we move or copy a parametric part. Simply copy the folder that contains the parts and their tables. Let's associate this table with my drawing. Variable function, define table with question, indicating the path and the question. Inform table position. In the previous example, the questions to define the variables L and H were also defined. Leaving these questions, what will happen? When the part is inserted into a drawing, the system asks the questions for variables L and H, and then the table will be processed. Let's cancel the questions. Note that the table command was also stored at the end of the list. Reposition it before the rectangle. Creating a new part with the name PD2. Opening the R0 drawing again. And inserting the PD2 part that contains the table. Choosing the second row of table variants. See the result. Showing the list of variables. Is possible to individually reprocess parametric parts. Reprocessing part 2 with table. Reprocessing part 1 with questions. This way, by associating tables, you can create parametric drawings with dozens of variables and hundreds of lines of constructive variants. If you have designs that use families of parts associated with tables, using this feature is very practical.